In this video, we will be focusing about finding the equations of tangent and normal lines to the given graph. We can recall that the derivative of a function can be interpreted as the slope of the tangent to the graph of the function. Say we have a figure that looks like this. Graphically, the tangent to a curve at a point is the line that touches the curve at that point and has the same slope as the curve at that point. The normal line, on the other hand, is the line that is perpendicular to the tangent at that point. The equation of the tangent is given by the point-slope form of the equation of a straight line in analytic geometry. That is, where m is equal to the value of y prime, or the slope of the equation. Now, since the normal is perpendicular to the tangent, then its slope is the negative reciprocal of the slope of the tangent. Hence, the equation of the normal line is Now, let's try an example. Let's say we have the equation of curve at the point -4 and 2. First, we should find the derivative of the equation. That is, y prime is equal to -y over x. Recall that the first derivative of the equation is also the slope. Therefore, we can rewrite it as m equals to negative value of y, which is 2, over the value of x, which is -4. Therefore, the slope is positive 1/2. We can now substitute this value to our formula. For the equation of tangent line, we have we now have the equation of the tangent line to the curve. Next, in finding the normal line, we have Now we have the equation of tangent and normal line to the curve xy equals 25 at point -4 and 2. For the next problem, we have the equation of the curve y squared is equal to 6x at point 2, 1. Next, find first the derivative of the equation and substitute the values of the coordinate in order for us to get the slope. Now that we have the slope, we can now use the formulas in finding the tangent and normal lines. Now we have the equation of tangent line and normal line to the curve y squared equals to 6x at point 2, 1. Now that's all for this topic, and thank you for listening.
Hi guys, in this video, I will be focusing about understanding the concept of the angle between intersection of curves and how to find this angle using differentiation. To begin, let's observe the figure shown. Consider the curves y equals to f of x, y is equal to f sub x, which intersects at point p sub 0 at x sub 0 and y sub 0. The angle between two curves at the point of intersection may be defined as the angle between their tangents at this point of intersection. Therefore, it will look like this. Let phi be the angle between these tangents, which is also the angle between the curves. Here, we can see that the angle phi is an acute angle which is measuring less than 90 degrees. We let theta 1 and theta 2 be the inclination of the tangents t sub 1 and t sub 2. Now, how can we solve the angle phi by using these inclinations? We can solve for phi by subtracting theta 1 from theta 2. So, the equation will look like this. Then, taking the tangent of both sides, we get here, we can see that it is a trigonometric identity, the difference of tangent angles, which can be written as. However, this can also be written as the slopes of the tangent t sub 1 and t sub 2. The sign of tan phi is positive or negative depending upon the values of m sub 1 and m sub 2. If tan phi is greater than 0, then phi is acute. And if tan phi is less than 0, then phi is obtuse. But it is customary to find only the acute angle of intersection between the curves. Therefore, we may use the absolute value symbol. And our final formula would be tan phi is equal to the absolute value of m sub 2 minus m sub 1 over the quantity of 1 plus m sub 2 times m sub 1. Step 1 in finding the angle of intersection between curves is to find the point of intersection by solving the given equations simultaneously. Step 2 is to differentiate these given equations in order to find the slope of the curves, which we recall as m sub 1 and m sub 2. And lastly, step 3 is substituting these values of slope using the formula to find the angle of intersection of curves. To further understand these steps, let's have an example. Say we have the curves xy is equal to 25 and y squared is equal to 5x. First, we should find the values of x and y by solving simultaneously. For the equation 1, we can rewrite it as x is equal to 25 over y. This will become a temporary value of x. We can substitute this value to the second equation to find the values of x and y. Skip the long one. Now we have the value of y, which is 5. Here, we can solve for the value of x. Therefore, x is equal to 5. We now have the point of intersection at 5, 5. Step 2 is to differentiate the given equations. Here, we recall that the slope is the first derivative of the function. Therefore, our m sub 1 is equal to negative value of y, which is 5, over x, which is equal to 5. We now have the value of m sub 1, which is negative 1. Next is to differentiate the second equation. The slope of our equation 2 is equal to 5 over 2 multiplied by y, which is equal to 5. Therefore, our m sub 2 is equal to 1 half. We now have the values of m sub 1 and m sub 2, which we can use to find the angle of intersection of curves using the formula. Therefore, the angle of intersection is arctan 3 or 71.5 degrees. Now, let's try another example. Let's say we have xy squared minus 32 is equal to 0 and y is equal to x squared. Here, we can directly use the y value of the second equation to the first equation. Now we have the value of our x, which we may use to find the value of y. Therefore, the value of our point of intersection is 2, 4. Next is to find the slope of our given functions.
We now have the angle of intersection between the curves xy squared minus 32. We now have the angle of intersection between the curves y equals to x squared and x y squared minus 32 equals 0. And that's all for this lesson. Hello guys, in this video, I'm going to talk about how to find the maximum and minimum value of a function. The maximum and minimum values of a function refers to the highest and lowest point of the given curve. Say we have a curve y is equal to f of x. That looks like this. The highest point is called the local maximum and the lowest point is called the local minimum, which are also called the critical points, wherein the value of the abscissa of this point is called a critical value or a critical number. These points always has a tangent line which is parallel to the x-axis, which is the slope is 0. In order to find the local minimum and maximum values, we need to find the derivative of the given function. Say we have this function, where y is equal to 2x cubed plus 3x squared minus 36x. Differentiating the given function, we have y prime is equal to 6x squared plus 6x minus 36. Recall that these points has a horizontal tangent line where the slope is 0. Therefore, we set y prime to 0. On the right number, factor out the similar value, that is 6 multiplied by the quantity of x squared plus x minus 6. Multiplying both sides by 6, we get here we get the critical points. X is equal to negative 3 and x is equal to positive 2. We now test these values to find out which of them will give us a maximum or minimum value of a function. Substituting the value of x, which is negative 3, we have 2 negative 3 cubed plus 3 negative 3 squared minus 36 multiplied by negative 3. Here we get y is equal to 81. Our x is negative 3 and y is 81. Next, substituting the second value of our critical number, which is 2, we get cube plus 3 times 2 squared minus 36 times 2. We get the value y equals to negative 44. The greater y value will be our maximum point and the lower y value will be our minimum point. Therefore, this point is our maximum and this point is our minimum. Now, let's try another example. Say we have y is equal to x cubed minus 3x squared plus 2. Differentiating the given function, we have 3x squared minus 6x. Setting y prime into 0, we we get the critical values x is equal to positive 2 and x is equal to 0. Substitute these values to the given function to find the ordinate. Y is equal to 2 minus 3 multiplied by 2 squared plus 2. We obtain y is equal to 2. We obtain y is equal to negative 2. Next, substitute 0 to the given function. We have y is equal to 0 cubed minus 3 times 0 squared plus 2. We obtain y is equal to positive 2. Therefore, our critical point is 0 and 2. The greater y value will be our maximum point, and the lower y value will be our minimum point. Now, if you want to take a look at the graph will look like this. Our maximum critical point is 0 and 2. Therefore, the point should be here. Our second critical point is positive 2 and negative 2. Therefore, the point should lie here. Now, in order for us to draw the exact form of the curve, we can use a number line and find a number greater and less than our critical numbers 0 and 2. Say we have negative 3 and positive 3. Substitute these values to our given function to find the y values. We have y is equal to x cubed minus 3x squared plus 2. Substituting x as negative 3, we have y is equal to negative 52. Note that it is negative, therefore it is decreasing. So it will look like this. Next, substituting as x is positive 3, we have 3 cubed minus 3 multiplied by 3 squared plus 2. We have y is equal to positive 2, which is increasing. Recall that our critical number 0 is a maximum and the critical number 2 is a minimum. Therefore, the direction should be like this. Following this direction in the number line, the graph should look like this. And that's it for this video.